Part 4, we got L-Nadzami.
Part 4.
Part 3.
2.
I thought you just did 1 and 2.
Oh, all right. It's the second recording. Okay, part 3.
Part 3. Part 3, we got L-Zami. We got K-Sing.
It's K.
Yeah, what's K?
Her name's Rachel.
Oh,
You think
I'm doing the wrong one, yeah.
Yeah,
Fine, my bad.
Wow, you're going to have to go back and redo that whole recording.
It's hard.
We got, no, K is just, nowadays, the kids call anything K. Like, K Money. Just because.
No, usually that's when the kid's name starts with a K. Yeah.
Yeah.
All right. Yeah. All right. Next one. Periodic table. This is very important. If they don't know how to read the periodic table, they are not passing the Regents. So let's make sure they know how to read it. Okay. First thing, this is a definition question that they're likely to ask. How are the elements arranged in order of increasing atomic number? I hope they realize by now goes 1, 2, 3, 4, 5, 6, and then it's labeled here as atomic number. Okay. Organization of the periodic table. They need to know anything in the same column. Okay, don't let them think row. Some of them really don't know the difference. Column. Anything in the same column has the same number of valence electrons, and that makes them chemically similar. If they ask why, tell them we don't care. Noble gases, the ones at the end, everyone knows by now, has 8 valence electrons. They're very happy. We know the octet rule. We'll discuss it a little later, but they don't need any more. 8 electrons, they're happy. Great. Oh my God. The elements, like we said, very important topic. Elements in table 4, increasing atomic number. Again, same question, except they now replaced atomic number with number of protons, so choice 4. Rubidium and cesium have similar chemical properties because they all have the same electrons in the outermost shell. I don't know if it's 1 or 2, you gotta look it up. Which element has atoms that can form halide ions? Okay, halide is gonna be in group 17. All right, so FClBrI, it's gonna be iodine. At STP, which substance is a noble gas? I don't know, look at group 18, neon. Which group on the periodic table has elements that tend not to bond? Group 18 again, the noble gas. Identify the element in period 3 that's unreactive. Same thing as not bonding. So in period 3, period is a row. All right, now they're going to get very mixed up, but it's labeled on their periodic table. Explain in terms of atomic structure why they rarely form compounds. Notice they love the noble gases because they have 8 valence electrons. They're very happy. Explain in terms of electron configuration why arsenic and antimony are chemically similar. Same number of valence electrons. Okay. All right. Metals, nonmetals, and metalloids. Right. First, we need to know the different phases of matter. It's not difficult. Most of them are solid. There's only 2 liquids. They need to know them. Hg, which is mercury, and Br, which is bromine. Those are the ones that are in blue or dark in the black and white version. And then gases, obviously the noble gases, which is why they're called noble gases, and anything with a letter H, O, N, F, and Cl are all gases. Right. Now, metals, nonmetals, and metalloids. They need to know which is which. Anything below the staircase, metal. Anything above the staircase, nonmetal. Anything touching the staircase is a metalloid, except the only one touching it that's not is right here, aluminum. Okay, there's only 7 metalloids. All right. Let's see, which list represents non-metals only? You're looking now above the staircase. Contains metal, non-metal, and a metalloid. Again, you're looking at the whole staircase thing. Which one's a gas? It's going to be xenon because xenon is a noble gas. You'll see it in group 18. Which one's a liquid? Remember, you only need to know 2 liquids, mercury and bromine, so it's going to be bromine. Which group has 3 phases of matter? It's going to be 17. That's the one that has bromine in it, and it has solids and it has gases. Which group on the periodic table has 2 elements that exist as gases? That's going to be group 17. It has F and Cl, right? All right. Okay, periodic trends. This is very stressful, but there's no reason to memorize this. No reason. This booklet, the reference table that they give you, has everything on it. Don't sit there, don't let them sit there memorizing periodic trends. If they see a question about periodic trends, meaning they're going to ask, like, what happens to atomic radius as we go down or across a period, whatever, don't let them sit there memorizing it like this. Dumb, I put it in there just for, like, effect. Pick an element from the beginning of the row, pick an element from the end, and compare the radius, right? If it goes from 100 to 363, atomic radius increases as we go across. Suggest to them, though, that when they're picking from the beginning and end of a row, don't pick noble gases because they're special. They tend to, like, be different, let them pick like from 1 and from group 17. And if they're asking about a column, pick the top one and the bottom one. Okay? They ask about for ionization energy, electronegativity, and atomic radius, which are all in there, so no reason to memorize. Okay, which one has the largest? Look it up. As the first 5 elements in group 15 are considered in order of increasing atomic number, meaning group is a column. So as we're going down the column, what happens? Look it up. It's never going to be decreases. This is not a thing. Which statement describes the general trends in electronegativity and atomic radius? Also in the chart. Same thing, electronegativity and ionization. It's so dumb for them to memorize it. Just look it up. All right, allotropes. 1 question per test, usually on the first page on the right column. All right, so you know where to look out for it. Some nonmetals can exist in 2 or more forms. That's called an allotrope. For example, you have O2 and O3, oxygen and ozone. Okay, or you could have carbon, which is in diamond and graphite. Those are basically the only 2 examples ever given on the region. So if they ask, like, what's the deal with diamond and graphite, they have different structures or different properties. That's usually what they ask on. So let's see. 2 forms of solid, here it is, carbon. Diamond and graphite differ because they have different crystal structures. Okay, here is again, diamond and graphite, they have different crystal structures, different properties, choice 4. The same question over and over. Now they switch to oxygen, O2 and O3, molecules with a different structure. Okay, oxygen exists in 2 forms, they have different molecular structures and different properties. Same question every year. Don't get it wrong, don't let them get it wrong.